we've done the basic simulation of the particles now. So we've got them sort of animating over the surface of the character. So the next step is to transfer them from the static mesh to the animated version. So if I just unhide both of these meshes, so that's a static one, and then we've got this animated one, and they're both exactly the same. That one I just duplicated at the beginning, so topologically no difference. So we're going to use a node called get closest location, and what that does is we're going to feed in, let's just hide that one, we're going to feed in the point positions of the particles, and then we're going to say in relation to that point position, what's the closest point on this mesh to that particle. And we're going to do that for every single particle in the particle system, and then the get closest location will output the points on this surface that are the nearest to each one of these particles. And then because these meshes are the same, we can then take those locations, apply them to the particle system, so replace the particle system point positions with the locations on the surface, and then reapply them to the animated surface, because the closest location is based on sort of surface geometry and not world position, so we can just easily reapply it to an animated one like that. So let's do that. So I'm going to need to bring in the animated geometry, which I haven't brought in yet, and I'm going to need to get the mesh. So I'm just going to do a pass, which lets you sort of plug in an input, and then you can just use multiple outputs of that. It's just basically letting us take that input and just dragging it over here. So then this doesn't do anything to it, it just basically lets you plug in a single input and have multiple outputs coming out from the same thing in a different part of the graph. So we've got, let's call this static mesh, just so we can get it clear. Static mesh, and that one's going to be the animated. So I'll just put animated after that, so we know it. And I'll just put animate mesh. Animated mesh. Right, let's hide this. Let's get some more viewing space for our graph. So let's make a get closest locations. That one. So we want the geometry is going to be our static mesh. We're going to need some point positions from the particles. So I need to make a node get point positions and just plug the particles into that, and then plug that one into there. So that's that done. So now this is finding the closest locations on the mesh to each of the particles. Then we need a node called sample property. Oh, I put the snib. Sample property. There we go. And this has inputs for locations and geometry. So locations go there, and the geometry is going to be the animated geometry. So we're going to find the closest locations on this geometry, but then we're going to sample these locations on the other geometry and output point positions. So we just have to change that to a mass float 3, because the point position is a vector 3, well not a vector, float 3. So we've done that now, so that's basically it. So it's not that complicated, you just got to make sure you get this in the right order. Static mesh into your closest locations, particle point positions into the positions, and then locations into a sample property, and then the important step is the animated mesh goes into the geometry. So this sample data now is all the point positions of the sampled locations but on this mesh, and then we just need to reapply that, or basically convert the point positions of the particles to the point positions on this mesh. So we just do set point position. There we go. So we plug in the sample data, which is the new positions on the mesh, animated mesh, and then we just plug in the geometry of the particles to let it know that it's the particles we want to change the positions on, and then we just plug that into our output. So now if I go H, and then I hit rewind, you can already see the particles are on the guy. Let's move this over. And we can see we're animating along. Let's just move him along. Ooh, there we go. And we can see that difference to the original geometry, the particles were slightly floating over the surface a little bit, because these locations are literally on the surface of the object. They all get snapped right to it, so you get really nice surface particles. So that's it. Let's just go through that one more time just to look at the graph again, and let's maybe lay that out a bit better. So here we are, particles, get the point position of the particles, we get static mesh geometry. In the closest locations we pipe the static mesh into the geometry, the particles point positions into the positions. The locations of that we put into a sample property, which we're getting the point positions on that sample on the geometry, but we're not sampling on the static geometry, we're sampling it on the animated one, which is exactly the same as the static, just animated. And then we're outputting those point positions and we're reapplying them back onto the particles, and then we're outputting that, and that's it. So that's the particles done. I'll just do a quick video showing you how to do it with strands.